I want to work a few of the questions I posed in the lesson. Our example was about pulse rates. So it says here, data from the National Health and Nutrition Examination Survey shows that the mean pulse rates for women between the ages of 20 and 55 is 74 beats per minute, with a standard deviation of 11.3 beats per minute. So I want to encourage you, as I mentioned in the text of the lesson, to sketch these problems out before you jump right into using our StatCrunch tool called the normal calculator. The question for this, number one, is what is the percentage of women that have a pulse rate less than 80? So I'm going to encourage you to sketch it out. The first thing I want to do is sort of identify some keywords in the problem. Some extraneous numbers here, but it said there was a mean of 74 beats per minute and a standard deviation here, my standard deviation of 11.3 beats per minute. So that's important to note. And then when I look at the actual request, it says, what is percentage of women have a pulse rate less than 80? So 80 here is going to be our X. Actually label this X. So let's give this a quick sketch before we jump in. There's my bell curve. Do your best to draw them. At the bottom, I'm going to put the mean. It goes between at the bottom. Now, we showed in the lesson that the pulse rates of women in this age bracket do indeed follow a normal model. So you can look back in the lesson to see why I quickly sketched this for the problem. I'm going to draw my tick marks, 3 of them spaced out to the edge, equally spaced out. And I'm going to add a standard deviation each time I go out. So add 11.3. Again, and one more time. I'm not going to bother with the right hand or the left hand side since the question they asked about was 80, which is already something I can locate on the number line I've drawn. So I'm going to put that one in. And I'm going to put it in right there between 74 and 85.3. 80 would fall somewhere in there. So that's sort of a vertical line I put into the model and split this curve up a little bit. Now, the last thing I'll inspect in this problem is to find a percentage, I need to know which part of the model I'm going to shade. If I look at the language here, it says less than. So less than to me means to the left. So I'm going to shade to the left of 80. So that little rainbow region I created there with a neat little marker is the actual answer to my problem, but it's not a number. It's just a nice visual. So I'm going to use StatCrunch to find the portion of this normal model that I have shaded. Go to StatCrunch, bring it up here. That's something I was working earlier. We'll navigate in, Stat, Calculators, all kinds of ones, Normal with a bell curve. And what StatCrunch needs to know is what's your mean. So you give it the 74, the 11.3, that's standard deviation, shortened and abbreviated there. And here is where, notice X is inside this parentheses, you're going to put in your value 80. That's where you stopped along the axis, drew a vertical line, and initiated some shading. And here, you can see, you have 2 choices. You have a less than or equal to and a greater than or equal to. Less than or equal to means you're going to shade to the left. Greater than or equal to means you're going to shade to the right. Now, I've already have this set up in my head because I've sketched it, so I know I'm going to shade to the left. So I've got everything set. I'm going to hit compute, and a new number pops in. That's this number here. I'll highlight it out to about 3 decimal places here. There we go. And the blue there, that's my solution. That's telling me as I try to get I'm going to click this little button here at the top. You see it now dark. It's going to give me the empirical rule ticks. And it doesn't do the decimals, but it does to the whole number at least. It says that 70%, as that 0.702 was, 70% of the curve, or 0.702 as a number between 0 and 1, is being shaded here. That's roughly 70%. And that corresponds to the percentage of women that will have a pulse rate less than 80. So I'm going to come back, work with this a little bit. So it says what percentage? So I'm going to respond to that question there and say that is 0.702 is my output, which is equivalent to 70.2% of women. There we go. And because I like to do everything fully, that means that this region, if I can, is 0.70. I don't know if that would have been better accomplished in black here, 0.70. So that is, the answer we get is the proportion that's shaded, and that's our percent there. Let's try the second one, see how things are going to change. What's the probability that a randomly selected woman would have a pulse rate greater than 95 beats per minute? Again, draw the curve. Let's label it. Oops. 74. Well, let's see, 85.3, 96.6, and 107.9. And only labeling the right because I have a value here. If I look in here, this here is the value they're curious about. That's going to be my X. And if I put that in right to the left of 96.6, this is where 95 goes. And if I examine here and look quickly at the language, it said greater than that. So I'm going to shade to the right, the pulse rates that are greater. I have this little region there, and that's the region I'm going to seek out and see if it matches with the input I will put into StatCrunch. So I already have the mean and standard deviation loaded in there from my last problem. So let's start editing. 95 is the new X, and we talked about how I want to be greater than it. I don't even have to press compute. I will anyhow because it always makes me nervous. The picture is exactly right to the left of 96. I drew my little line and shaded to the right. So StatCrunch is giving me exactly what I need. So here it is. We'll look at this out to 3 decimal places. I see that the decimal place beyond 3 is 5, so I'll round up. And I'll go back here and write out my answer. So I'm going to write this one a little more formal. The probability that X is greater than 95 is equal to 0.032. That is the region, if I can fit it in there, that's how much of the curve is being shaded there. In this far right tail of the curve, we call those the tails on the edges. And that's the probability. Lastly, slightly different situation. I wanted you to see all of these. What is the probability I randomly select a woman and find that her pulse rate is between 60 and 80 beats per minute? One last curve. Put the 74 in the middle, the 85.3, the 96.6, the 107.9, and to the left, see if I can do some subtraction. I get 62.7, I believe, 51.4. Let's subtract 11.3 one more time. So this time I fully labeled these tick marks. This is a bit over the top. You don't have to label everything. Just a general sketch is fine. So let's see. So I have that set up. So now I notice it gave me two values here, 60 and 80. These are two different values of x I'm curious about. So let me get them on the graph. 60 would be, looks like about right here. 80, we did that before, it's about right there. So two different values of x, two different pulse rates, and they're asking for the between. So I'm going to shade between these, all the women that would be between these two. There. So again, curious about what that is. Going to use a sophisticated calculator to do this, but I have my game plan in front of me. Come back here. Now, right now, I can't enter that in the way it looks. I'm going to need to choose between. Standard gives you one box to compare x to. Between gives you two boxes you can edit to compare to x. So the lower one goes to the left. Oops, take away that negative. 60 to 80. Now again, I still have my mean and standard deviation for my first two problems. I'm sort of riding the wave of that. And I'm going to press compute. And I get the same picture I drew for myself. So I'm feeling pretty confident that StatCrunch is doing exactly what I intended to do. Technology is a powerful thing, but you got to know how to work it and understand what it's doing. So if I go out to 3 decimal places here, come on, there. There's my probability, 0.594 with the 5 of the neighbor. So I'm going to round up to 0.595. This is the probability. So it's giving me, again, the shaded region there. It's about 60% of the curve is being covered there. Almost finished. Come back here. And again, try to write this in a way. Probability. It's a little shaky for me right now. The probability is between 60 and 80, we saw, was 0.595. And that's the probability. That's the likelihood, if you chose a woman at random, that she would have the pulse rate between these two values. So again, I don't know if the red will show it better. This is 0, doesn't look like it, 0.595. So you can now see that StatCrunch has just a neat little calculator to give us the area of these shaded regions under the bell curve.